Hey, 6th grade, how's it going? Today is Thursday, August 20th, 2020. Good to have you here. Today you're going to need your 6B book, Prime Math, and we're going to be working on page 101, 102, 103, and if there's time, 104. If you didn't check out last time's video, please check out this link, which is on my YouTube channel, just because it gives you a better idea of what pie graphs are and how to analyze them. We were able to look at different types of pie graphs, understand the importance of putting a title on the graph, as well as look at the different types of data that are represented in the graphs. So let's get started today. On page 101, you'll see that the first problem talks about students in school. It says the pie graph shows how a group of students travel to school. Letter A. How many students go to school by bus? If you look at the number, bus is represented by 16. Letter B says how many students cycle to school? Well, another name for cycle is bicycle, which you can clearly see is 12 students. And letter C asks how many students are there altogether? With this one, you have to add up all the numbers. So if you add up 16 plus 12 plus 8 plus 4, you're going to get the full number, the total, which is 40. Check your answers to make sure that those are correct. The next question, letter D, says, what fraction of the students walk to school? Well, if we take the number that walk to school, which is 8, and we compare that to the total number of students that are going to school, we can come up with a fraction, okay? So let's try to figure that out. Let me try to, make sure to see if I can, there we go, okay. We take the number of students that are walking, which is 8, and we compare that to the total, which is 40, which can also be made into a simpler fraction. If I divide 8 and 40 by 8, that's going to give me 1/5. So that should be 1/5 of the students walk to school. And letter E says, what fraction of the students go to school by car? Well, we know that there are 4 students that go to school by car. So if we have 4 over our total, which is 40, and we divide each side by 4, 4 divided by 4 equals 1, and 40 divided by 4 equals 10. So those should be our 2 fractions. Let's check them to see if they are correct. All right. So we have 40 students altogether. 1/5 of the students walk to school, and 1/10 of the students go to school by car. Next, page 102 has us looking at a pie chart that shows different types of vehicles sold by an automobile company last year. As you can see in the pie chart, each number is represented by a quantity. This time we're not looking at percentage just yet. Letter A says, which type of vehicle had the highest number of sales last year? Well, all we really have to do is just look at the number that is the largest or the highest number. In this case, it would be cars, which is 4,000, compared to the other numbers, which is much bigger. Letter B says, how many trucks were sold? Trucks represents 2,000 of the total number of vehicles. And letter C says, what was the total number of vehicles sold? Again, we need to add up each one of the numbers. 4,000 plus 2,000 plus 3,200 plus 800. This can probably be done in your head, and it is 10,000. If I did that correct, let's hope. All right, yeah, 10,000 vehicles were sold total. Let's go to the next letter, letter D on page 102. Letter D says, what fraction of the vehicles sold were vans? Well, if you look at the vans, we have 800, and the total again is 10,000. So we need to compare the fraction 800 as our numerator over 10,000 as our denominator. We could use a calculator if we really wanted to show that. 800 divided by 10,000. It's going to come up with a decimal, I believe. Yep, 0.08 or 8 hundredths. Okay. But we could also show that with a fraction. 800 over 10,000, which I can show right here. All right. I'm going to divide both sides by 100. So once I divide both sides by 100, my final answer is 8 over 100, which is the same as our decimal we got from our calculator. And I can divide both sides again by, let me see, is it 2? No, 4. I can divide both sides by 4. Let's try that. Divide 8 by 4 and divide 100 by 4. It's going to give me 2 25ths. 2 25ths is my fraction of vehicles that were sold that were vans. All right. So let's see if that's correct. 2 25ths is my answer. Letter E says, what fraction of the vehicles sold were buses? Well, if we look at the number of buses, we have 3,200, and the total is 10,000. So let's take a look at this. Buses represents 3,200. And our total, again, is 10,000 vehicles. If I divide both sides by 100, it's going to give me 32 over 100, or 32 hundredths. Okay, 32 hundredths can be simplified. That can be a simplified fraction. I can divide both sides by at least 2. Let me see. Let me divide 32 by 2. That's going to give me 16. And divide 100 by 2. That's going to give me 50. And I can divide that again. Make that even smaller. I'm going to divide this side by 2 and divide this side by 2. So we have 8 25ths as our simplified fraction. Let's see if that's correct. Check our answer. All right, we have 8 25ths as our answer. Okay? Again, you want to make sure that your fraction is as simple as possible. Let's go to page 103. It says the pie chart represents the number of different colored beads that Betty has. Letter A says, how many yellow beads and how many blue beads does Betty have altogether? Well, the number of yellow beads that Betty has is represented by 150. See that right here? All right, 150 yellow beads. And the number of blue beads is 100. So 150 plus 100 is 250 total beads. So that's our answer, 250. Let's check to make sure that we did that one correct. Okay, letter B says, how many green beads does Betty have? We don't really know the number of green beads. If you look at the pie graph, right? We know that each one of those, yellow and blue, represent 250. And we know that the red is represented as 50. But here's something interesting to know. If we split this in half, okay, we can split this pie graph in half. I'm going to represent that with purple. If I can change the color, give me 1 second. If I can change that. All right. If I split this pie graph in half, I know that 250 represents 50% of the data because this is half of the pie graph. So if this is 50%, then this is 50% also. I already know that red is 50, so I can take 250 minus 50 to get 200. My answer of green beads is 200 green beads. Let's check that to make sure that we did that correct. All right, once again, total number of yellow and blue beads was 250, and the number of green beads is 250 minus 50, which equals 200. Letter C says, how many beads does she have altogether? Well, it's pretty simple. You just have to add 150 yellow plus 100 blue plus 50 red plus 200 green, and you would get give me a second, you would get 500 beads. Okay, good. So we have 500 beads all together. Let's read letter D. Letter D says, what percentage of the beads are blue? Well, we know that 100 beads are blue. So since we can compare the quantity to a percent, what we can do is take 100 blue beads over the 500 total beads, multiply that by 100%. We can simplify our fraction, and we come up with 20%. 20% of the beads are blue. Letter E says, how many times as many yellow beads are how many times as many yellow beads as red beads are there? We know that there are 150 yellow beads, and we know that there are 50 red beads. So how many times bigger is yellow than red? Well, 150 divided by 50 gives us 3. Obviously, the yellow portion is 3 times as large as the red portion. Let's go to page 4, 104. The pie graph title says that it represents Henry's savings, okay, the amount that he spends for his savings, right? If you take a look at the pie graph, you'll notice that we don't have any percentages, but we do have quantities in dollars, right? And then we also have that representation of clothes, which has an interesting angle that's being represented there, right? That's a right angle. We'll talk about that in just a second. Letter A says, what fraction of his savings did he spend on books? Well, once again, just like our problem from before, we have half of the pie graph represented as books, right? You can see that. Let me try that again. Half of this is books. So this right here is 50%. Okay? So the same fraction would equal 1/2. All right? 1/2 of the books, 1/2 of his savings is spent on books. In other words, letter A is 1/2. Letter B says, what fraction of his savings did he spend on stickers? Well, stickers is $5. So if we know that $5 is the amount that with the stickers, what we can do is we can try to figure out that 1/2 was books, right? And clothes was 1/4 of that percentage. Let me show you a little bit clearer with these fractions, okay? We know that 1/2 of the percentage was books. And we know that any number that has a right angle, okay, equals 90 degrees. Now 90 degrees is 1/4 of a circle. If we go all the way around from this point, all the way around, we make a circle, just like our pie graph represents. And 90 degrees is just 1/4 of the whole thing. In other words, 360 degrees would equal 100%. Okay? This number of clothes is represented with a 90-degree angle. In other words, 1/4 is the same as our 90-degree angle. So, what fractions are left to be represented? If we have 1/4 represented with clothes, 1/2 represented with books. Well, I know that 1/4 plus 1/2 plus a certain quantity is going to give me 1 whole. So if I take 1/2 plus 1/4, remember when we add fractions, we need to have the same denominator. And 1/2 is the same thing as 2/4, right? This is 2/4. So in other words, 2/4 plus 1/4 equals 3/4. And 3/4 plus some number equals 1. In other words, 100%. But these two representations are what's left. So how do we split this quantity into two? Well, we know that 3/4 plus 1/4 will give us 1. And if we split 1/4 into two sections, we know that 1/4 divided by 2 equals 1/8. So the fraction that he spent on stickers was 1/8. In other words, 1/8 equals $5. Now that can get kind of complicated, boys and girls, I understand, because we're trying to relate not only a degree amount to a fraction, but also a fraction to a quantity, and the quantity to the entire pie graph that's represented. Okay, so this is getting a little bit complicated. Let's try letter C to see if we can understand this concept a little bit better. Letter C says, how much were his savings? Well, if we know that, for example, we know that $5 was his toy amount savings, and $5 was his sticker amount savings, and 1/4 was his clothes savings. 1/4 plus 1/8 plus 1/8 plus 1/2 is going to give us 1. In other words, his total amount, right? Well, we already know that 1/8 equals $5, and another eighth equals $5. So what we can do is we can take $5 plus $5 to also equal our 1/4. Well, 5 plus 5 is 10. So 1/4 equals $10. And if we double the $10, we can come up with our 1/2, which equals $20. So let's add up 10 plus 5 plus 5 plus 20. That would be $40. So in other words, our whole number equals $40. Let's check that to make sure that that's correct. All right, good. 1/8 equals $5, so 8/8 or 1 times the $5 unit equals $40. You can see it's done in a little bit different way on the top, but we still came up with the same answer, $40. Letter D says, what percentage of his savings did he spend on clothes? Well, we know that we just figured that out, actually. Problem should be before letter C. Let me just try to explain it one more time. If we know that $5 was spent on toys and $5 was spent on stickers, we can just take 1/4 plus 1/4, 1/8 plus 1/8, okay, of the toys, right, plus the sticker amount, which was also 1/8, to give us 1/4. In other words, $5 plus $5 equals $10. So our amount that he spent on clothes should have been $10. the percentage of that would be 25%, okay? Because 90 degrees, in this case, here we go, look at this, 90 degrees equals 1/4, which also equals 25%, okay? If you show that in pictorial form, for example, this amount of clothes represents 1/4 or 25% of the total. This is 25% plus 25% plus 25% plus 25% equals 100% total. Okay? Let's do that last problem, letter E, and finish up this page. Letter E says, find the ratio of the amount spent on the toy car to the amount spent on books. Let's check that out. So we have toy cars, which is $5, to the amount spent on books, which we know is twice the amount. I'm sorry, not twice the amount. Let's see, we have 1, 2, 3, 4 times the amount. Okay, so 5 times 4 is going to give us $20. All right, so the ratio would be 5 to 20, which we can simplify to 1 to 4. That is the ratio of the amount of toys to the amount spent on books. 1 to 4. All right, these problems are getting kind of complicated, boys and girls, and I understand that this can be confusing. This topic can be a little bit confusing because we have to not only understand the relationship between the quantity, but also relate that to our understanding of fractions and percentages, which we've been learning about over the past couple of months. We will continue to practice these types of problems, and we'll get better and better about our understanding of this topic. So, until next time, we'll see you guys later.